Hey guys, today we're starting Unit 3 with classifying triangles and talking about triangle congruency. Alright, so let's just start by first classifying triangles by their angles. And this should be pretty simple for us. If it has 3 acute angles, it is an acute triangle. If it has 1 obtuse angle, it is obtuse. 1 right triangle means it is or 1 right angle means it is a right triangle. And if it has 3 equal angles, it is equiangular. So we have this figure here, and what I'd like for you to do is pause your video for a minute and see if you can identify what each triangle is based on what you see. Okay, so the very first obvious one that I saw was ABE, which is right here. ABE is equiangular because it's got these 3 little tallies, okay? All right. Let's see. And then I have, let's look at CDE, this triangle right here, that has a right angle. So it is a right triangle. So that was CDE, just to keep track. I don't have enough colors today to highlight everything, but I'm going to try. Okay. Let's see. BCE is the next one. So BCE, and that is an obtuse. Obtuse. Let me highlight that yellow. Okay. BDE is next. Let's find BDE. Okay, BDE is this outside triangle. Outside triangle. And so it is going to be obtuse because it's got this larger than 90-degree angle here. And finally, we have CFE, which I'm just going to kind of color it pink in here. CFE is an acute triangle. Acute triangle. All right. So we've classified them by their angles. Let's go ahead and classify them by their sides, which is equally as simple. Okay. If they have 3 congruent sides, they are equilateral. If they only have 2 congruent sides, it is isosceles. And if they have no congruent sides whatsoever, it is scalene. So far I know all this is review. Now let's try to identify this down here using all the tally marks, okay? So the first one that stands out to me really very quickly is the equilateral triangle. It's KJN. Oh, here it is. They have it labeled as JKN, but same thing. This is equilateral. Alrighty. The next triangle is KLN. And I want you to notice that it's got 2 tallies here on this side and this side. Those double tallies mean that those 2 are the same, and then this bottom edge only has 1 tally, so it is a different angle measure. So this one is isosceles. Okay, and then the last triangle that we have, let me switch colors, is JKM. So it is JKM, this entire triangle here. And it does not have any sides that are marked the same. No sides marked the same. So this is going to be scalene. Okay, so let's talk about how do we, in the coordinate plane, how do we determine what type of triangle we have if they just give us points? So this is kind of a transition, like you did this in Math 1 when you learned about the distance formula, okay? So the distance formula and the Pythagorean theorem really give you the same information. So the Pythagorean theorem is a squared plus b squared is c squared. Or you could use the distance formula, where the distance is the square root of, and I'm just going to put delta x and delta y. Okay, delta means the change in something. So you would just subtract x2 minus x1, y2 minus y1, and then square root everything. Okay, so delta, let's just make a side note here. Delta, change, okay, in something, or difference. Okay, all right, I know that's kind of sloppy and squished in there, but delta is the change in something. So we find the change by taking the difference. So let's go ahead and classify this triangle with these vertices, okay? So I'm going to start by plotting their points, which is why I included a graph here. So -4 up 3, this is point A. +1 up 4 is point B. And then point C is -1, -1. So this is our triangle. Okay. And so you can really choose to use whichever theorem that you want to. Okay. I'm just going to go ahead and use the distance formula. So let's find the length of AB. Okay. So this would be 1, and this would be 1, 2, 3, 4, 5. So 1 and 5. Okay, and so I write it like this. Okay, 1 squared plus 5 squared. That's going to be the length of AB. Let's find the length of CB. I'm just going to go ahead and find them all right now. So CB, I kind of do mix the Pythagorean theorem with the distance formula, if you notice. 1, 2, 3, 4, 5, 1, 2. So 5 squared plus 2 squared. And I guess I can go ahead and color these as well so that you know which side I'm doing. So AB was yellow. Okay. And then finally, the last side. 1, 2, 3, 4. 1, 2, 3. Okay. So 3 squared plus 4 squared and square root, and that is AC. So now it's just simplifying all of these, okay? 1 squared and 5 squared is the square root of 26. 5 squared and 2 squared, that's 25, and 4, that's 29. And then 3 squared is 9, plus 4 squared is 16. That is the square root of 25, which is just 5. So if I can simplify it all the way, I can. But I can already tell you that this triangle is scalene because none of their square root values were the same. So 26, 29, 25. Scalene. So you don't even have to simplify or convert these to decimals to figure this out, okay? They already are not the same numbers here. All right, great job, guys. Let's go ahead and flip this over. Let me find my blank paper. And we're going to start talking about some congruent triangles, okay, with some new vocabulary. So triangles that have the same sides and the same angles are congruent. This means that corresponding parts are sides and angles, are going to be congruent. Okay, so we will need to be able to make some congruency statements. So you will need to recognize, okay, triangle ABC, the A comes first, is congruent to triangle DEF, the D comes first. And that's kind of how we match up which angle comes first in each triangle. You can also tell by looking at the tally marks. This is one little scoop in the corner. This is only one little scoop in the corner. Side FE has 2 little lines. Side BC has 2 little lines. So those 2 sides are going to be congruent, okay? We're going to get some practice here in just a minute with doing that. And then finally, let's talk about CPCTC. This is a hot mess. Okay. So, and one of my children used my highlighters over the weekend, so I'm missing 2 colors, which is a shame. But here's what this stands for. Congruent parts of congruent triangles are congruent. So we don't want to write this out every single time. So we just write C, P, C, T, C. That's how we do it. Okay. And then I'm out of another color. I could try something. Let's see, red. Will red work? Okay, there we go. Try to add some color for those. Congruent parts of congruent triangles are congruent. So if we can say all the angle measures are congruent to another angle measure in the other triangle, and all the sides from one triangle to the next are congruent, then the whole triangles are congruent. So here's our example. Given that these two triangles are congruent, complete each of the statements. Okay, so here's where paying attention to the order of the letters that they give you come in handy. So K is congruent to A. So let's come right over to the side and just start filling this out. Angle K is congruent to angle A, and congruent, let's see, angle P is congruent to angle Y, PY. Okay, here's what else we can say now. Let's see, we have PK. PK from blue to red is congruent to YA. Notice I go from blue to red, okay? YA. Let's use a different color. Got blue, red, let's do green. M and C, okay? So KM is red to green. So AC is red to green. And let's do our last one, CY. That's green to blue. So we need to do green to blue, M to P. Colors really help me out when I'm doing this, okay? And now let's talk about angles. Angles. If you remember that when we label angles, we always put the angle in the center. Okay, so here they asked for angle Y. Here they're asking for angle C, but they want me to give it to them in a specific way. So ACY is red, green, blue. So when I give them this angle, I need to do red, green, blue, which will be KMP. All right. And then finally, let's go ahead and do our triangle. So I just did color coding here. Let me go ahead and do my tallies too, okay? It'll help us see things. K, A, blue, and there's going to be 3 little lines there, okay, for the P. And now let's do our sides. So red to green and red to green are congruent. Green to blue, green to blue. I'm going to put 2 little tallies. Red, blue is that side. Red, blue. Okay, so this is what our triangles look like. I was a little messy on that one there. It should be 3 lines. So now we're going to say triangle MPK. So that's green, blue, red. It's congruent to, let's do green, blue, red. CYA. CYA. And then triangle YAC. So blue, red, green. So let's do blue, which is P, to red, to green. Put that triangle symbol there. All right. Whew. So those are all of our congruency statements for that triangle. We have one last example to do in our notes for today, okay? And it is if they give me the values of the sides of these triangles and they tell me some congruency statements, can I solve and find the values, okay? So they told me triangle UVW, UVW. So UV is going to be congruent to TS. Okay. So one statement that I can make is that 12x minus 7 is equal to 53. Okay. The next statement I can make is they tell me that VW is congruent to SR. VW in SR. So on that side, I've got 5y minus 33 equals 57. And I'm going to scooch my paper over in a second. And then in blue, I've got, okay, UW is congruent to TR, which is this side down here. So that is 3Z plus 14 equals 50. So I've now used the congruency statements to set up these three equations to solve, okay? So let's go ahead and start to solve these. So 12x equals 60, x equals 5, okay? Add 33 to the other side. I get 5y equals 90, and so y equals 18. And then let's subtract 14, and then divide by 3. I get z equals 12. Okay, so that's it, guys. We're just using congruency statements now for triangles. Angles and side lengths. Today we kind of focused on, with our one example of solving, just doing side lengths, but the same type of problem could be solved using angles, okay? All right, there's a practice assignment posted for you on Canvas. That's it for today. Until next time.